So I have taken out IAR workbench, not Proteus. We'll do it on IAR workbench. On Proteus, it's the same. I had shown you one video on how to implement it on Proteus. It remains the same. So now here, if you look at it, I've typed out the same program. When you're creating a project, please make sure that you select the project as C program. Okay, C project, and the extension is here .c. Till now the extension was .asm. The extension when you're doing a C program should be .c. Everything else remains the same. So it's the same program. Just scroll it down. It's the same program. It's toggling the LEDs. So now, as usual, we have to build. Okay, the build is over. There are no errors, and we can download and debug. Okay, so I'll not explain the program because we have already gone through the program. We'll just look at the registers. We'll look at the port register. So port. So now here we know P2 out is negation of LED 1. So LED 1 was bit 3 was 1, right? If you go back and see, in LED 1 we had defined bit 3 as 1. So negation would mean that bit 3 is 0, all the rest is 1. So if we do that, here we can see it has changed. P2 out, if you see, bit 3, that is P3 is 0. All the other bits are 1s. Similarly, next, it is P2 DIR. When you are doing it, please do it with P1. So P1 DIR is equal to LED 1 odd with LED 2. So the third and fourth bits of P2 DIR will be set. So let's just execute that line. Okay, that line is executed, and P2 DIR if I extend, see, it is P3 and P4 have been set to 1. So that sets the direction. So the third pin and the fourth pin are set as output pins, and you can connect your LEDs there. Then going to timer A. So next let's take timer A here. So that was port. Next we will group with timer A. Okay, so in timer A we are telling TACC R0 should be 49,999. So once that line is executed, if we go here and see, we will see that the number is 49,999. So your timer A will run, TAR register will run till 49,999, go back to 0, and then the interrupt comes in. We are setting the bits, required bits of TACTL. That also we can see here, the TACTL has changed. Now we are telling double underscore enable underscore interrupt. So now where can we see that? We are setting the GIE bit. So to see the GIE bit, we have to go back to CPU registers and see SR. So here if you look at SR, as of now, GIE is 0. Once we execute this line of code, okay, it comes here. 1 second, it is put timers, it won't work with 4. We'll set it to 0. I'll just rebuild it once, because otherwise so coming down to that line of code, this is where we were, and GI is as of now 0. Now once this line of code is executed, we can see that the GIE has become 1. Okay, so we are done till there. It has come to the low power mode. Now when we execute this line of code, the low power mode 0, so we'll execute it. So we have to pause it because it's in an infinite loop. You will not be able to see. So pause it for a while. Pause. You can see CPU off has become 1. So if you go back to the table, we know that all the other 3 bits, that is the SG0, SG1, SCG1 and OSC off are 0 and CPU off is 1. And in order to show that it is a low power mode, you can see that the dark green has changed to light green. Okay, the light green, it is just symbolizing, it is a simulation. It is simply symbolizing that we have shifted to a low power mode. Okay, now once it remains in the low power mode till the interrupt comes. Okay, now we will force the interrupt. So to force the interrupt, we go to the particular interrupt. So the interrupt is timer A0. So this is the interrupt. Click, right click on it and force. Okay, now when we force, we have forced the interrupt, and when we go through again, we have to press on, go to again, and it has come. Now you see it is again dark green. Why? It has exited from the low power mode, and here it will toggle the P2 out. As I told you, please when you are trying it, please do try it, type it out and see. When you are trying it, if you want to do it on Proteus, you can use P1 and you can use 1111 or you can use 20. If 2013 is not available, I think in Proteus, you can use 1111. So here, go through, see P2 out, you will see that it toggles. Again, when I continue, I press F10 again, it goes back. So it goes back to the low power mode and stays there till the interrupt is forced again. Okay, we are forcing the interrupt because it's a simulation. When you do it on Proteus, you will not have to force the interrupt because your TAR register will run. Okay, so that is all with the C program. We will do the ALP tomorrow.